Cool. So today we're gonna be looking at question number two. Add two numbers. Um, so from the question description, you're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their node contains a single digit. You add the two numbers and return it as a linked list. So notice how these two linked lists are in reverse order. So basically, you're starting off with the last digit, and then the 10th and the 100th. But the result is always is as well in reverse order. So you don't really have to reverse any linked list in this case at all. So the way to approach this problem is basically you just add these two. The way to add is go through the two lists element by element, and you want to sum them. And there is one trick, or to say one important key aspect, is how you add two numbers in decimal spaces. So for example, if you had a number A and number B, and the new result you would think normally is just A plus B mod 10 and A plus B divided by 10 to get the new numbers, but there is one implicit, or to say the extra piece here, which is the carry number. So the way you use these approaches, using so the single digit update is A plus B plus carry mod 10, and the new carry is updated by exactly the same. Instead of mod, you use the division. So to approach this problem, there is one explicit assumption made here, is that you can modify these two list nodes, or else you need to make a copy of them first, or to say use a temporary list node to traverse through these two list nodes. But I'm just gonna go through them, which is gonna be easier. So because list node, it's they are linked one by one, so there is no explicit memory allocation for the ending result. So there is no such thing as a O(n) space requirement. It's really just O1. So regardless, if you, for example, if you want to modify on L1 and then you just return L1 itself, which is okay, or if you want to make a new list node and then return that one, which is okay as well. I'm just gonna make a new one, which is a little easier in the sense. Notice how I have to use a number over here to construct it, because that's the only constructor provided, and I'm just going to use a t as a temp to point to my current read. To t is going to be the traversal list node in this case. So while on L1 is available, or to say L1 is not null, or L2 is not null, so in this case I'm basically saying that either L1 or L2 exists. I'm gonna have two values. A is L1. If L1 is null, I'm just gonna give it a 0, or L1.val. And B equals to L2 dot val, or 0 if L2 were a null. And the new num, which is going to be just this calculation, and of course I do need a carry here, so I'll just define it as a 0. So you're going to be looking at A plus B plus C mod 10 for the current new number, which is going to be the new list node, and the C is going to be updated by this formula. A little sloppy over here. So T, when you enter this loop, T is still on re. You can of course change T itself, but let's just say I start off with re as the new 0, so I'm just gonna point onto the next one, which is easier in a sense when you think about it. So T.next is this, and update the carry, so T moves on to T.next, and L1 is L1.next, and L2 is L2.next. Of course, well, I have experienced this before, so if L1 were a null, you can't move on to next, so you need to make a adjustment over here. So if they were null, you just don't care about it, or they move on to next value. And at the very end, you need to take another you make another judgment over here whether it's the carry is greater than 0 or not. Well, if it were greater than 0, then you do need to make the next to the current travel a new list node of 1, because C is really just either 1 or 0, and then you just return re.next. So that should do it. And it shouldn't. Okay, so I guess the speed works, and that's question number 2.